All right, here's part 2 of your final exam review. In part 2, we start with 21. In number 21, they're saying the revenue in thousands from producing X units of an item is modeled by R of X is equal to 5X minus 0.005 X squared. Find the marginal revenue at X equals 1,000. Okay, so if you recall, to find marginal revenue, in this case, find the first derivative of the actual equation, which is going to land us at 5 minus 0.001x. Remember, it's multiply and take away 1. So 5 times 2 is 10, so hence we eat one of the decimal places. So this becomes, I think I actually made a mistake here. There should only be one place, so let me just double check it with calculator. Early in the morning, folks. I'm recording this bright and early. So 0.005 times 2. Yeah, so it's 0.01, my mistake. So the idea here is if we're checking this at 1,000, we're going to do 5 minus 0.01 times 1,000. And in this case, I'm getting 5 minus 1. So it should be $4. All right, number 22. 22, you need to remember that the average cost, let's see, it says the total cost to produce X units of paint is C of X. They want the marginal average cost. So average cost in general is the original function over X. So if we take our function, let's go ahead and FOIL it. So we start with C of X is equal to the 5X plus 3 times the 7X plus 4. And first, outer, inner, last, we end up with 35x squared plus 21x plus 20x plus 12. And all of this over x. So that's your original C of x. And if we consolidate this, the C of x, once we gather like terms and divide by x, leaves us with 35x plus 41 plus 12 over x. Remember, I'm simplifying x's. To find the marginal value, we would simply take the first derivative, which is plus 1 divided by 1. I'm sorry, multiply by 1, subtract 1. So we end up with 35 minus, remember this comes up as a negative, so this becomes negative 1 times 12. So you get minus 12, take away 1 and bring it down. You get x squared. And so I believe that is our function. (23), we bounce back to the first derivative apparently. So it says find the first derivative. If you're given f of x is equal to x to the 8th plus 7 times e to the x. Remember, this is 7 times e to the x, and so the derivative never changes for that practically. you end up with, in this case, 8x to the 7th plus 7e to the x. This never changes. And you'll find then when we do the antiderivative that that's the case. 24, same thing. This time it's a natural log of x, so they're giving us f of x is equal to the natural log of x to the 4th power. And okay, and sorry about that interruption. This becomes, they want us to find the first derivative, so f prime x. You need to remember that natural log x to the 4th is really 4 times 1 over x, which is really, in this case, 4 over x. That's our first derivative. So just to rekindle this, remember it's power rule, hence 4 times the natural log of x. So 4 times 1 over x. Just to remind you, this is how we end up here. All right, number 25. Number 25, they're giving us find the first derivative given f of x is equal to 3 times natural log x, same as prior question, so it's like a little warm-up, and natural log x to the 7th plus 6 e to the x. So remember, this is merely 3 over x plus 7 over x plus 6e to the x. These are like terms, same denominator, so we can really simplify to 10 over x plus 6e to the x. So that would be our first derivative. All right, number 26. Use appropriate properties of logarithms to rewrite f of x and then find the first derivative. Okay, so we have the original f of x is equal to 1 plus the natural log of 5 over x squared. I'm sorry, x to the 4th. We're going to take the first derivative. The first value cancels, right? And this becomes power rule, which if it's power rule, we have 5 over 4 times the natural log let's say natural log. Am I complicating this? This is actually very simple. This is just the negative 4 over x. Because remember, the 5 is like a constant, so it kind of dissipates. You end up with x power of 4. So if it's natural log of x power of 4, if you bring this up as a negative, this is natural log x negative 4. So it becomes negative 4 times natural log x, which is negative 4 times 1 over x. So, number 27. Now we're talking about product rule and derivatives. So we're given f of x is equal to 3x minus 5 times 4x to the third power minus x squared plus 1. Now this is a very easy process if we're going to find the first derivative. Remember, we're going to take 3x minus 5 and we're going to take the 4x cubed minus x squared plus 1. This is the original f of x values. We're going to now take the derivative of each separately. So this becomes 3. This derivative is 12x squared minus 2x. I always say, since the quotient rule is the one that has the most pressing of the order because of the subtraction involved, use the same rule in product rule, because product rule is just addition. So we take 3 times 4x cubed minus x squared plus 1. To that we're going to add 3x to the minus 5 times 12x squared minus 2x. This gives us 12x cubed minus 3x squared plus 3 plus, this is going to give us 36x to the third power minus 6x to the second power minus 60x to the second power plus 10x. Okay, now we combine the like terms. Let's see what we get. Okay. Let's do yellow. We'll do the thirds. So this and this add up together to give us 48x to the third power. The squares. That's going to give us negative 69x squared. And then the 10x is left alone plus 3. And I believe that is our answer. All right. Number 28. In number 28, we have find the first derivative. They're giving us f of t is equal to 0.4 t times 5t squared plus 1. And if we distribute, we get 2t to the third power plus 0.4t. And now we take the first derivative. So our first derivative results in 6t squared and plus 0.4. And I believe that is our answer. All right, number 29. Again, differentiate, find dy over dx of x cubed. So this is our f of x, result in x cubed over x minus 1. And same thing here, this is quotient rule. The latter two were product rule. So we start with the first term, x to the third. We differentiate that, that's 3x squared. Second term, we have x minus 1. And when I differentiate that, I have 1. So again, use the same notation, and in this case, remember, it becomes 3x squared times x minus 1 minus, and this is why I say use the same process for quotient rule, is x cubed times 1. I'll just write it just for the sake of reminding you. And all of this is over the denominator squared, so x minus 1 squared. All right, so a little distribution. So we get 3x cubed minus 3x squared minus x cubed, and all of this over x minus 1 squared, which gives me 2x cubed minus 3x squared over x minus 1 squared. And I believe that is our answer. All right, number 30. Find the values of x where the tangent line is horizontal to the graph of 4x squared over x plus 2. Horizontal means x equals 0. That's what they're referring to, horizontal. Keep that in mind. They're giving us f of x is equal to 4x squared over x plus 2. All right. So we're going to use our quotient rule to find that first derivative. And so we start with the first term, 4x squared. Take that derivative. Take the x plus 2. Take that derivative, and then we use the same process. So we're going to start with 8x times x plus 2 minus 4x squared times 1, and all of that over the derivative, or the denominator, x minus 2 squared. So we distribute. We're going to get 8x squared plus 16x minus 4x squared all over x minus 2 squared This results in 4x squared plus 16x and that's over x minus 2 squared. All right, and we factor out the numerator. We end up with 4x times x plus 4. So one of our values is x is a 0. The other value is minus 4. They're asking us where the line is horizontal. And technically that has to be x is 0 and x is negative 4. They just want the values of x. We're done. Okay, number 31. Number 31, they give us f of x is equal to 8x minus 9 to the negative 4th power. So this is chain rule, not product rule or quotient rule. This is just simply chain rule. So first thing we're going to do is we're going to multiply, so you get -4, parentheses, 8x minus 9, take away 1, this is to the -5, times the derivative of the inside, which will give me 8. Now, -4 times 8, well, that's 32. And I'm going to write that over the 8x minus 9 to the +5. I'm bringing it down. And I believe that is our answer. All right. Let's see. Number 32. We have x squared plus 2 to the third power. Again, that's the equals f of x. We want the first derivative, so we'll apply chain rule, which is 3 parentheses x squared plus 2 to the take away 1 second degree, and the derivative of the inside, which is 2x. This reduces to 6x times x squared plus 2 squared, but we can go further and go ahead and factor this, so you get 6x times x to the 4th plus 4x squared plus 4. And if I distribute the 6x into this trinomial, I'll get 6x to the 5th plus 24x to the 3rd plus 24x. And I believe that is our answer. Number 33. They want us to simply, once again, find the derivative using the chain rule. So we have 5t squared minus 4t, and all of that squared. They want this in a specific form, so the first derivative would be 2 times 5t squared minus 4t to the first power. So that'll simply give us, I forgot to do the 10t times the derivative on the inside. So that'll give us, I believe, I have a little faux pas there. The derivative of this will be this. This is our answer. Remember, you always take the derivative of the inside. Be careful. Number 34. Okay, so the first thing you want to do here is find the equation to the tangent line to the graph of the function given the value x equals 1. So they already gave us the x value. We need to find the y value. So that means that f of 1 is equal to 1 squared plus 31 to the 4 over 5 degree. Okay, so this is going to give us 4 over 5, technically times 32. Take away 1. Remember, you're subtracting 1, so you're really subtracting 5 over 5. So you have now -1/5. That's a 1. Times the derivative of the inside. Since this was originally x squared, we're going to go with 2. And so you end up with 0.8 Well, if you multiply this together, though, if you multiply 2 times the 4/5, that's going to give you 8/5. Let me just multiply it straight across at this point. So 4 divided by 5 times 2 times 32 raised to the negative 1/5 is 0.8. 0.8 translates right back as a fraction to 4/5. Okay, so we have now the slope. And we know that when x is 1, so we know in this case, for example, that let me see, 32 raised to the 4/5. Okay, so we already know because of this, we already know before you even take the derivative that this is 16. So we know the value of y, basically. So we know 16 is equal to 4/5x plus, and now we have to find b. When we multiply this, we'll subtract. Let me see here. If x is 1, 16 is equal to 4/5 plus b. So I'm going to subtract 4/5 on both sides. Remember, we need a common denominator, so we end up with 76. So we have the equivalent of 80 minus 4/5, which is equal to 76/5. And that's the value of b. So our equation will end up being y equals 4/5x plus 76/5. And I believe that should be our answer. Okay, number 35. In number 35, we are given the equation f of x is 4,500 minus 4x squared, and they're asking us to evaluate this at x is 20. They want to know the percent rate of change of f of x is indicated as the indicated value of x, which is 20, and round to the nearest percent. So if we take that first derivative, we have negative 8x, and the percent rate of change in our case is the first derivative over the original f of x. So the first derivative is negative 8 if we use 20, and divide that by 4,500 minus 4 times 20 squared. You end up with negative 160 over 2,900, which comes to negative 0.055. In other words, negative 5.5%. And I believe that is also our answer. All right, here's number 36. Use the demand equation to find the revenue function. So they're giving us x is equal to f of p, and that is 30 times 15 minus p. So we have 450 minus 30p. Use the antiderivative for this. use the antiderivative. So we end up with 450p minus 30p squared. If we factor, let's see, we have to do that? No, we don't need to factor. We actually are just fine. I believe that is our answer. Okay, let's look at 37. Determine the intervals for which the function given f of x is x cubed plus 18x squared plus 2 is decreasing. So one of two things, you can place this into decimals, or you can, I went ahead and I found the first derivative. And in doing so, I got 3x squared plus 36x. And I factored out 3x from both sides, so leaving me 3x times x plus 12. And that gave me 0 and negative 12, which are partition numbers. Let's look at the second derivative, which I did look at the second derivative. I don't think I need to go that far. I think this is our answer. If you were to take the second derivative, what do you get? You get 6x plus 36. So I think we're good. If I factor out 6, I get x plus 6. So negative 6 is already telling me that we're good here. You can also throw this into decimals, which graphing calculator, decimals, either one will work. Go back. So if I were to focus this here, I get x raised to the third plus 18x to the second plus 2. And if you notice, they're simply asking you where it's decreasing. So you have to scroll a little bit. Okay, a lot of it. You can always take the first derivative, by the way. Let's go ahead and do that. 3x raised to the second will give us a better let's take a gander and see if it shows us a little bit more clearly. I'm hoping that I can get a nice visual. Let's see. I'm gonna go to the origin so I can see. Okay. We're looking at 0 and we're looking at 12. Again, I think I'm really off here. If I go all the way here. Patience. Okay. Yeah, you can see it decreases at 0, it decreases. You can see it also here as you scroll. See right here at 12. Look at that number. In this case, x is negative 12. Let's see what happens down here, positive 12. Well, I did get negative 12. I was negative 12, not positive. My apologies. That's why I was having an issue. So you can see, yeah, if you, again, Google it, put it in a window, narrow your window, you can see that it's decreasing between 0 and negative 12. Remember, I tend to be kind. I will not torture you with questions that are going to drive you crazy. All right. Let's look at 38. 38. 38 is more of the same. 38 is actually a little bit more manageable on the graph. So you start with a first derivative, or that first displacement function. They give us 3x to the fourth minus 6x squared plus 7. We take the first derivative. We're going to get 12x to the third minus 12x. The 7 cancels. If I factor out 12x, I'm left with x squared minus 1. So that means that I have 0 and I have plus or minus 1, because this factors further. Remember, this is a perfect square. This is x plus 1 times x minus 1. Typo. Sorry. Okay. So those three numbers are where our function, if I look at the function at -1 and 1, this function is going to come through here at some point. It's going to come back down through 0. And I'm purposely being kind of light on the pen. And it's going to come back this way. Let's see if it shows up on Desmos. I'm curious. So what do I have? I have 12x to the third power. Sometimes they show really nicely, and sometimes they're such a nuisance to look at. So you see that little cluster right there? That's what I'm looking at. So look at those points. See, that's what we're striving for in 37 and 38. We like to see it nice and clean. It isn't always that cooperative, so remember. Okay, next number is 39. Let's take a look at 39. So number 39, we have f of x is equal to x cubed plus 3x squared minus 24x plus 6. It says use the first derivative test to determine the local extrema. So we'll take the first derivative. That gives us 3x squared plus 6x minus 24. If I take out a 3, I have x squared plus 2x minus 8. And if I factor this, I'll get x plus 4, x minus 2. So my solutions are -4, +2 in this example. Let's see what it looks like. Again, back to Desmos. So I'm going to put in 3x raised to the second. I'm sorry, I'm going to put in the original function, x raised to the third power plus 3x squared minus 24x plus 6. All right, and so we're looking at the x values. There's your 2. And there's your -4. If I bring it down just a smidge, you can see both. So we're just looking at the x values, max and min. Local max at x is -4. And your local min is that x is 2. All right, so that's number 39. Let's look at number 40. Here's number 40. It says find the critical values and determine the intervals where f of x is decreasing and where f of x is increasing. You're given f of x is equal to 3x to the fourth minus 6x squared plus 7. And so if we take the first derivative again, we'll get our hints where this is happening. So once again, look at what's happening. I'm factoring out 12x, so that question is revisited. Here's x squared minus 1. So there's your zeros, here's 0. And this gives us plus or minus 1 because, again, just to remind you, this is x minus 1 times x plus 1. So factors are positive 1, negative 1. And if I graph this, let's go back and graph the original. And again, we're revisiting. They give us 3x raised to the fourth minus 6x raised to the second plus 7. And you notice a little cluster happening right here. There you are, right there. Boom. There's one. There's the other. All right, I'm going to pause this second part of the review and I'll continue the third.